Now, in this video clip, we will determine the domain and the range of function f of x equals x squared plus 10x plus 25. First, we notified that this expression is actually a complete square because we know 10 divided by 2, which gives us 5. And when we square 5, we get 25. So this expression is a complete square, which is f of x equals x plus 5 squared. Those two are equivalent. They are the same. You may try by FOIL method on this one, because x plus 5 squared is x plus 5 times x plus 5. You will get this one. Okay. All right. Then we know this is actually x minus 5 squared. You may say plus 0. Okay. This is actually the vertex form. Vertex form. Vertex form, the vertex is x is this number, which is -5, and y is this number, 0. So -5, 0. And then if we sketch this graph, that will be y equals x squared plus 10x plus 25. Then you can see here is -5, 0. That's basically this one, vertex. We can see from here, x can choose any value. X can choose any values. Okay, so then here the domain is what? The domain is all the real numbers. That's the domain. Okay. Then what is the range? The range is all possible values for y. This is our y. Y equals what? Y equals x plus 5 squared. Anything squared is greater than or equal to 0. At the point x equals -5, -5 plus +5, you got 0. So that's, again, basically this point, right here. So then, what is the range? The range is written clearly as y greater than or equal to 5. Okay, that will be the range. All right, if you want to write in the set notation, that will be y. Sometimes people use column or they use vertical line. Then describe that. This is the description, okay, to show y greater than or equal to 0. And then here is the representative element, okay? That will be the range. All right, now let's look at another one. Another one we want to do is the one right here. We want to determine where the function is increasing, where the function is decreasing. Solution. Increasing is if xy is less than x2, you have f of x1 is less than f of x2. So when we draw this picture, we have a y equals negative x squared plus 8x minus 7. So you can see here, 1 is less than 4. We can see right here. You see 1x value is less than 4. Then what do we get? We get 1x is 1 f of 1, which is y value, which is 0. Is the value right here. X, this one, x, this point is 1, 0. So x is 1, y is 0. And then when x equals 4, you have a y value is what? Is 9. The reason you plug in here, you have a negative 4 squared. Remember, that's like this. Negative is outside of this squared. You see right here? And then plus 8 times 4, and then minus 7. So you then have a negative 16 plus 32 minus 7. This one gives you 16, and then you then minus 7, so it gives you 9. This is how we got 9. Okay, x is 4, then y is 9. So you have what? You have a 1 x is 1, which is less than 4. Then you have y value, 0 is less than 9. So this tells us what? That's the example. So when x gets bigger from the left to the right, x gets bigger from negative infinity. You have a y gets higher and higher. You can also test this one. You see 0 is less than 1. Negative 7 is less than 0. So when x value is smaller than this value, then y value is smaller than this one. We see negative 7 is less than 0. Okay? So you see here, this is negative 7. So then where is increasing, where is decreasing? Then you may say from negative infinity, you may want this pencil. Let me erase this one, rewrite it. better. From negative infinity to 4. Then in this interval, f of x is increasing. Okay. Then in this interval from 4 to positive infinity, f of x goes down. So you see from here, then goes down, falling down. Then f of x is decreasing. All right. So that's basically, if you want to use the abstract, the expression, that's if x1 is less than x2, decreasing will be what? This one will be reversed. Okay. So when x value is less than another one, function value here is actually reversed. You can see right here, this point. 4 is less than 7, but 0 is less than 9. 7 is bigger than 4, but 0 is less than 9. Okay, so the concrete example for decreasing will be opposite. Okay, so that's final answer for this one. All right. Okay, I will see you next time.